This video is over lessons 33 and 34. Lesson 33, writing percents as fractions, part 1, and lesson 34, decimal place value. Take a few minutes to copy this down into your notes, and then when you're ready, hit play again. Moving on in 3, 2, 1. As we consider how to change percents into fractions, we need to remember that we can always replace something with what it's the same as. And so if we think about the word percent, we know that per means divide, and cent, like century, centimeters, cents, and a dollar, means 100. So a percent sign can be replaced with divide by 100. So for example, if we have 33%, I can rewrite this by replacing percent with what it's the same as. So 33 is still 33, but instead of the percent sign, we're going to replace it with divide by 100. Now, since I want to rewrite this percent as a fraction, I'm going to take my division problem now and write it as a fraction. So the first number, the dividend, goes on top and becomes my numerator, and the second number, the divisor, goes on bottom and becomes my denominator. We need to check to see if we can reduce. One of the nice things about having a power of 10 as our denominator is that we can check and see, can this be reduced by 2? Can it be reduced by 5? And if the answer is no to both of those, then it can't be reduced. Well, the answer is no to both of those, so therefore 33% is 33 hundredths. Let's go ahead and try another one now. This time, let's do 28%. The 28 is still 28, but percent can be replaced with divide by 100. Again, we're going to change our our division problem into a fraction. And now I check to see, can I reduce this? Well, can't reduce it by 5, but I can reduce by 2. Now, just because I can doesn't mean I have to. I could look for something bigger, though. And for example, here I'm going to choose to reduce this by 4 over 4. 28 divided by 4 is 7, and 100 divided by 4 is 25. Well, still can't reduce by 5, and now I can't reduce by 2 anymore, so therefore I'm done. 28% is 7/25. Quick reminder, remember that checking for 2 and 5 is a trick that you can only use if the denominator is a power of 10. And let's do one last example. 45%. So 45 stays 45. Percent gets replaced with 100. Now we can rewrite our division problem as a fraction, which would be 45 over 100. This can obviously be reduced by 5 over 5, which then gives me 9 over 20. This cannot be reduced by 2. It can't reduce by 5, so therefore I'm done. 45% is 9/20. Moving on in 3, 2, 1. Before we take a look at decimal place values, let's quickly review whole number place values. I am going to put the decimal in right there, and then our first place value there is the ones. the next place value is the tens, and the third is the hundreds. Together, these three place values make up the ones group or the base group. And from here on out, we're going to have groups of three that will repeat ones, tens, and hundreds. So our next group here is the thousands. So I'm going to have a 1,000s, a 10,000s, and a 100,000s. Although we don't call them the 1,000s, we just call them the thousands place. And then the 10,000s, and the 100,000s. If we continue on to the next group, we're going to be in the millions group. So we're going to have a 1 millions, 10 millions, and 100 millions place. But again, we don't call it the 1 millions place, we just call it the millions place. And then next is the 10 millions. And then finally is the 100 millions. Now let's consider, what would it take if we had 100 million to turn it into 10 million? Well, one way would be to subtract 90 million. But that pattern's not going to work so well if I continue. So 10 million down to a million, I can't subtract 90 million again. But if I take 100 million and go down to 10 million, I could do that by dividing by 10. And then if I have 10 million and I want to go down to a million, I could do that by dividing by 10. And if I had a million and I wanted to go down to 100,000, I could do that dividing by 10. 100,000 to 10,000, divide by 10. 10,000 to 1,000, divide by 10. 1,000 down to 100, divide by 10. Take 100 and you want to get it to 10, divide by 10. 100 divided by 10 is 10. And of course, 10 divided by 10 gives me 1. So now that we have this pattern established, we can apply it to find the values of the decimal places. So if we continue dividing by 10, I'm going to start putting my red loops above here. To find the next place value after the decimal, I'm going to take 1 and divide it by 10. Well, 1 divided up into 10 different groups gives me 1/10. So therefore, this is the tenths place. And now if you take tenths and divide them by 10, well, you're going to get 1/100th. So therefore, this is the hundredths place. And so what you're hopefully noticing here is that you can kind of think of 1 as the center of all this. And as we go here, we have tens, hundreds, thousands, 10,000s, 100,000s. But over here, coming out from the ones, we have tenths instead of tens, hundredths instead of hundreds, and so on and so on and so on. So if I just look at how my place values increase over here, it'll give me a hint as to how they decrease over there. So, tenths, hundredths, what comes next? Well, tens, hundreds, thousands. So this must be the thousandths. And now here's the spot where I find students regularly make a mistake. And many students after the thousandths will go on to the millionths. But remember, these are place values. We have to fill in each place value, not jump from one group to the next. After the thousandths is not going to be the millionths, because after 1,000, we don't get a million. After 1,000, we get 10,000. And so this is the 10,000ths. And if I keep going, after the 10,000ths is the 100,000ths. So over here, after my 10,000ths is my 100,000ths. And we could keep going. So the next place value after that will be the millionths, and then the 10 millionths, and then the 100 millionths, and the billionths, and on and on and on. Moving on in 3, 2, 1. So for example, if we're trying to find place values, let's look at 3.4507. If I want to know what place this 5 is in, well, I'm going to remember that the ones place is always in front of the decimal. And if we can just think of this as the center of the place values, and everything going out from here is kind of a mirror image, then I should be able to figure this out pretty easily. Over here, next to the 3, is the tens place, so that must mean that this is the tenths place. After that would be the hundredths place, so after this must be the hundredths place. So therefore the 5 is in the hundredths place. And we could keep going and going and going. And this video ends in 3, 2, 1.